Since XML is just a text file, at the basis of XML, you need to understand a little bit about character encoding. These are the ways in which characters are created from the ones and zeros in the XML text file. So at a high level, an important part of working with computer text, whether it's XML or not, is understanding character encodings. Character encoding describes how the bits, the ones and zeros that are stored in a file, are translated into characters. All right, so as we talk about XML, I've already introduced it in a previous video. We need to talk about it at three different levels: the levels of the characters, the levels of the tags, and the highest level, the level of the schemas, or some of the sort of theoretical things you can do with XML. Let's start with the characters. As we said previously, XML is just plain text. There's nothing fancy about the storage of it. You can open it in many different kinds of text file readers, and any program that can read and write text can read and write XML as well. An XML-aware application in particular, though, expects the file to have a valid XML syntax, which we are going to continue to elaborate on, in order to process the data that's there. Every XML-aware application will look for certain tags and will process them in its own particular way. And usually the data that's created is created with a particular program in mind, so that the tags and the intention of the program are in alignment. In an XML file, the first thing that is present in the file is called the XML Declaration. This is the line that we saw that started with the angle brackets and question marks and ended with the same. The XML Declaration is the first line of a file. It's required if you're using XML 1.1, and if it's not there, then the assumption is that you're using XML version 1.0. As a default, you should always have a declaration at the beginning of your XML file if you're creating it manually or writing a program that creates it, to specify the information like the information seen here. In XML 1.0, the declaration is optional and defaults are assumed. In 1.1, the declaration is mandatory. You're required to have it. And the difference between 1.0 and 1.1 is kind of technical minutia, but basically it resolved some differences between character encodings, different Unicode versions. The attribute encoding is what we're talking about today. This is optional. It talks about how Unicode characters are represented in this file. And then the last attribute is standalone, which is also optional, and it says whether or not this document can be validated without getting something else from the internet, getting another validation document, actually getting a schema. All right, so let's start with this beginning part. The beginning part is just template. We do an angle bracket, a less than sign, question mark, and then the text XML. That goes on the front. And then at the end, you have a matching question mark and greater than sign. This forms the brackets around the declaration. At the very beginning, we have our version, and you notice that the version word is not in quotes. There's an equal sign, and then 1.1 is in quotes. All attributes in XML are in quotes. The next thing we've got is the encoding of the document. In this case, the encoding is UTF-8, a kind of Unicode. And then lastly, we have our standalone tag, also yes being in quotes. Let's focus on encoding for a little bit. There are many different examples of encodings that could possibly be used. Some names of them include names like ASCII, that was one of the original encodings for text on computers, UTF-8, UTF-16, maybe ISO 8859-1, which is another name for Latin 1, which you might see when you save files sometimes in maybe a Microsoft Office document. At the end of the day, though, computers can't store anything except for zeros and ones. A file is always just a bunch of zeros and ones in a long line. And we group those bits together into groups of different sizes. So 8 bits becomes 1 byte, 1024 bytes becomes 1 kilobyte, 1024 kilobytes becomes a megabyte, 1024 megabytes is a kilobyte, and 1024 kilobytes is a terabyte, and 1024 terabytes is a petabyte. And there are a few other words that go beyond that, eta and zeta, for larger and larger amounts of data. Really, really big data. So as we group those bits together, there's still just lots and lots of zeros and ones. And so if we have a file, it's filled with zeros and ones. A character encoding is a rule for how we interpret those zeros and ones as characters. So here, for example, are some zeros and ones. I've broken them up into groups of 8s to represent bytes, and we could possibly take a particular character encoding and interpret these bits as characters. So in this case, if we look at each of those characters one by one, and we looked it up in a table, we would see that those bit patterns correspond to HELLO, the word hello, a space character, and then WORLD, world. Notice that the H is capital, and a capital H is different than a lowercase h. A lowercase h or a lowercase w would have a different bit pattern. As you look at those bit patterns, notice that the bits associated with the L's that occur 3 times are always the same, and as is the same with the letter O, whereas the E and the D, the H and the W are different from each other. That's because those bits encode can be thought of as encoding particular letters. This is ASCII. So ASCII is a way of taking 8 bits at a time and translating them into letters. ASCII always uses 8 bits per character, and as a result, or for various reasons, it can only represent 128 characters. And this is a problem because there are a lot more than 128 characters internationally if you think of all the different glyphs that are out there in the world. Any encoding, however, has some common characteristics. There is a character set, and by this I mean there are a certain set of characters that an encoding can represent. So for example, ASCII cannot represent an infinity character. ASCII cannot represent many different characters from the Thai language. So different kinds of encodings, ASCII, UTF-8, have a different set of characters that they can possibly encode. Each character encoding has a code page. This is basically a table that tells you the translation from bits to characters. Each encoding then can be used to create strings. A string is a word that we use to describe a sequence of characters in a row. So after we have turned those bits into a sequence of characters using an encoding, they become a string. Hello space world, for example, is an example of a string. So here are all the printable characters that are part of the ASCII encoding. You can see that all the letters from the English alphabet are there. You don't notice anything from the special characters, perhaps from Spanish or German. That was because when computers were first created, we hadn't quite figured out that there was non-English speaking people in the world. If you look at the ASCII code table, this is an example of one of them that's available on the internet, and it shows you how bits can be translated into the different characters. So if you look at the decimal column and you look at the number 65 in the top center there, you can see that 65 has a bit pattern of 0100001, and that gets translated into a capital letter A. So if in your file you have a 01000001, that will be interpreted as a capital A. Great. It's great. We might have strings like hello world or what is the weather ? Because question mark is one of the printable characters. We might have map of California with some capital letters in there. We might have a string like I received a 10% discount. Percent character is part of it. You might have his phone number is 555-551212 because numbers are part of the ASCII character encoding. You might even have the phrase please translate this with a colon. But then you start to run into some problems with ASCII. If you wanted to ask the Spanish question, ¿Dónde estás?, you would have some trouble because ASCII doesn't have an O with an accent, an A with an accent, or an upside down question mark as part of the character set. Swedish word smorgasbord, I'm not sure I'm pronouncing that well, has characters that aren't in the ASCII set as well. This word that I cannot pronounce in German, which is an amendment to a law, traffic law, has lots of characters that aren't in ASCII as well. A mathematical formula like infinity plus infinity equals infinity is missing characters in the ASCII set. You might have Egyptian hieroglyphics. For example, these characters set here, which has something to do with Egypt. And then lastly, if you have a string that contains emoji, ASCII can't handle emoji either. So what can possibly be done about that? Well, shortly after the rest of the world, besides the US, discovered that there were computers, the need for international characters came about. And so the character encoding for ASCII was quickly replaced by a character encoding called UTF-8 or UTF-16. Those are two different character encodings. They're both character encodings that support international characters, including Chinese or other Asian characters, Arabic, Thai, emoji, etc. UTF-8 is the character encoding that is native to Mac and Linux, and it's the default for HTML5. And what do I mean by that? I mean that if you open up a file and you look at it in a web browser, the zeros and ones that are in that web browser will be interpreted using the UTF-8 encoding to translate those zeros and ones into characters. Then those characters will be interpreted by your browser to present a particular presentation of your data. UTF-16 is the default on Windows. Kind of an interesting story about why those two would be different. One thing that's interesting about the differences is that UTF-16 is a little bit more efficient if you're using Asian characters, the glyphs that are part of Japanese or Chinese languages. So if you ever encounter problems with encoding, so here for example is a screenshot of Notepad being opened and getting a bunch of question marks in the file. Well, typically what will happen in an application that tries to open a file that has characters that are in it that are not part of the current encoding, it will represent those characters not with the correct glyph, but with question marks. So what has happened here is that the file has a bunch of zeros and ones in it, and the interpretation of those zeros and ones was made using the ANSI, A-N-S-I, character encoding. Well, that character encoding doesn't have glyphs, doesn't have a translation for bits into Russian characters, and so when it encountered those patterns, it didn't know what to do, and so it would put a question mark in there. If instead you opened this file using a different character encoding, those Russian characters would be faithfully rendered, for example in UTF-8, the default for HTML5. In which case Notepad says, oh, I can see that pattern of bits using the UTF-8 code page can be rendered, can be drawn this way. So sometimes if you encounter that kind of a problem, it could be because you're looking at a file using the wrong character encoding. Or the file was written in a different character encoding than you were anticipating with the program that you're rendering it in. Another thing you might encounter is something like this. Here's some text in which certain characters, the ones that are pink with the X's through them, may be understood, but don't have a character to render them in a particular font. So this is an example not of a program reading a character encoding and not understanding the character. This is a problem of a font being used that doesn't have particular characters available to it. So in this case, these characters appear to be mostly currency symbols which the font doesn't have, the typographer hasn't created a character associated with that font. So when the program tries to render that file, when it encounters that character that should be rendered as, I don't know, whatever looks like a Congo or Ugandan currency symbol, it tries to find it, but the font doesn't have one of those characters in it. So it has to render it as a box through an X through it. First example, the previous example was a case of a character encoding being bad. This is an example of the character encoding being fine, but the font not having an appropriate character to draw the character. All right. So the bottom line with character encodings, it kind of explains sometimes why you encounter funny characters in your documents. But at the end of the day, text is just bits. It's 0 and 1s in a file, and they get translated into text using a particular lookup table that's associated with the character encoding. If you use the wrong table and you try and translate a text document using the wrong encoding, a different encoding than what it was written in, you're going to get those funky characters. Even though it seems like a file is filled with characters, you might be dealing with characters. At the end of the day, computers only deal with bits, but often they are seen through multiple layers of abstractions, so that it can make it seem like you're working with characters. But really what the computer is doing for you is manipulating ones and zeros underneath. Funky characters mean mismatched encodings. If you have two systems that are communicating with each other, for example, a web server and a browser, both of those systems need to be clear about how they're encoding the text that's associated with their document. If they are not using the same character encoding, or they don't describe the way correctly that they're doing their character encoding, there can be some confusion. So typically a website will tell a browser to use UTF-8 to understand the bits that are there. The bottom line, when in doubt, use UTF-8. There are valid reasons to use other encodings, but you should have a very specific reason why you want to use one other than UTF-8. So as we think back to our XML declaration line, a less than, a question mark, XML, version equals, double quotes, 1.1 double quotes, and then encoding. What we're doing is in that line, we are specifying how the bits in the file should be understood so that we get faithful representations of the characters that we wanted in our document. That forms the basis of the XML document. And the basis of the XML document then gets built up as an interpretation of the tags, which will be the subject of our next lecture. Thank you for your attention.